In this video, you will learn how to operate the motor test bench and measure critical parameters such as speed, current, and torque. Plug in the AC power cord. Turn on the AC power. Open the protective cover. Connect the DC power cables, ensuring the polarity is correct. Attach the red connector to the positive terminal. Attach the black connector to the negative terminal. To connect the external power supply, use the auxiliary inputs. Connect the DC power cables, ensuring the polarity is correct. Attach the black connector to the negative terminal. Attach the red connector to the positive voltage terminal. Ensure the shafts spin freely. Check that no foreign objects are inside the chamber. Close the covers securely before proceeding. Turn on the power supply. Verify that the base voltage and current limit are correctly set according to the specifications of the motor being used. Now, connect the USB cable to the data panel. Connect the USB cable to the PC. Turn on the main DC power. One of the key features of this test bench is Safe Power Off. This safety feature stops the motors if the protective cover is opened or the red stop button is pressed. This button shuts down the main DC power and turns off both controllers. The main DC power button remains inactive until we release the emergency stop button. You can turn on the fan if required. Open the motion terminal. Connect both controllers one by one. Left window is for the drive side, and right window is for the load side. Set the drive side to digital speed mode. So we start with the configuration field, where we set the torque sensor limit. For now, we use the 1 Newton-meter torque sensor. If you're using a 5 or 10 Newton-meter sensor, enter that value here. Then, the drive bus voltage for us now is 48 volts. If you use a different value, enter it here, as it affects the computed electrical power. So, the underspeed and overspeed limits must be adjusted accordingly to stay within safe operating range. Underspeed should be at least 15% of the speed reference, and overspeed should be 30 to 50% higher than the reference speed. To compute the residual electrical power, simply press this button. The result shown is the residual power value for the system. Now, we move to the drive side and set the speed reference to 1000 RPM. Start the generic monitor. Keep torque and velocity active and observe motor performance. Set the torque reference to 0.09 and observe the graph. If we stop the monitor and click Auto Fit Chart, we see that the torque increases to a certain value and then the speed drops. Click Auto Fit Chart again and export the data. The error notification is because the motor jumped over the limit. So, every time before changing the limit, reset the errors. The same procedure was followed for 2,000, 3,000, 4,000, and 5,000 RPM as well. To analyze the data, we can upload the files and observe the graph. Then, we can set the x-axis to velocity and the y-axis to torque. This will generate the graph for all the data. Select Use Absolute Values and observe the graph for different inputs. We can use some tools like average points and observe the graph. We can also fill them. You can export the chart image in this format, which is suitable for use in reports. With these steps, you can safely and effectively operate the motor test bench, perform measurements, and test motor performance under various conditions. To learn more about operating this test bench, watch the other parts on our YouTube channel.